As you might have read, there is an interoceanic canal in the planning phase in Nicaragua that would cross the largest tropical lake of the American hemisphere, Lake Nicaragua. The canal is being planned to transverse Lake Nicaragua in 106-kilometer stretch of a total of 275 kilometers from the Atlantic coast to the Pacific coast. And you can see here the proposed route. I just wanted to present to you some of the most important aspects of the lake so you can appreciate what the impacts would be causing on the lake if the canal would be built. The lake is the largest surface water body of Central America and also the largest tropical lakes of all the Americas. It has an area of 8,000 square kilometers. So you can see its position in Central America and in Nicaragua. It is the 20th largest lake in the whole world and very close to Titicaca in area. I'm not talking about volume, Fernando. I know that Titicaca is much larger. So one of the striking features of the lake of Cocibolca is its extended shallowness. This was something that was not known when it was first proposed as the route of the canal before the Panama Canal was built, because everyone thought it's a great advantage to have the canal built because you can go half of the way or 1/3 of the way through a lake. But the problem is that it's very shallow, this lake. It is a shallow tropical lake. 60% is less than 9 meters of depth, and 37% is between 9 and 15 meters. Only 3% of the lake is over 15 meters. Some other important characteristics of this lake. So it's a shallow tropical lakes are very fragile ecosystems, and they have very different distinct nutrient dynamics. This was supported by Tundisi when I asked him before one of the events that we organized. So we know that this is a very fragile ecosystem. The lake is also exposed to a lot of wind action throughout the year. It's a polymictic lake. It never forms typical layers because it's constantly being mixed, and the sediments are always in the water column. So as a tropical lake, of course, it has a very constant high temperature between 25 and 29, and the differences in 24 hours in the temperature is greater than the differences throughout the year. This is very typical for tropical lakes. Somewhat over the watershed of the lake, the area is 23,000 square kilometers. 83% is located in Nicaragua, and 17% in northern Costa Rica, the watershed. The lake is also very special in that it has wetlands in some of its coast, 207 square kilometers, which is almost 1% of the area of the watershed. And here you can see the different wetland systems. The lake is undergoing eutrophication due to a change in land use in the last 2 decades. At this time, you have 75% is dedicated to pasture land. That means that there's a lot of deforestation that has been going on in the last 20 to 30 years. You have 8% agriculture, and there are still some forest lands of about 12.5. The geology is also very important because the change in soil use combined with the geology has caused an increase in erosion and sedimentation into the lake in the last 20 years. So that means, as following up on that, an increase in input of nutrients and contaminants. This has a great effect on the water quality, And we have noticed in studies of the last 15 years that the algae biomass has increased, and also the community structures of phytoplankton has changed to a more dominant cyanophyte algae combination. The lake still has quality for drinking water and irrigation, and recently it has been classified in a monitoring phase last year between mesotrophic and eutrophic. Currently, there are still communities which have their drinking water under treatment from the lake, populations of 60,000, 15,000, and there are still plans to have drinking water treatment for other populations and other communities around the lake. What are the possible impacts of the construction and operation of the Interoceanic Canal in Nicaragua? First, you have a risk of salinization, also removal and resuspension of sediments in the construction, lake hydrodynamics and wind action, and geology and the seismic activities. I want to go into these 4 impacts so we can understand it better. So the risk of salinization due to the intrusion of marine water in the lake, there have been some studies from the company that is developing the plan and the design for the Interoceanic Canal, where they have said themselves that it's a very crude first interpretation of the salt distribution in the lake, and they presented the conclusion that due to the density, the salt water will sink into the deepest zone of the lake and canal sections, building salt hotspots. Little did they know that the lake is very shallow and that the lake is polymictic, and that this will probably not happen. So a little bit to the canal specifications. The canal should have a depth of 28 meters. As I mentioned above, the lake has an average of 11 meters. And this would secure, the difference between the Panama Canal and this planned canal would be that it would secure the transport of the largest vessels, which are now being used in transport, the container ships and very large crude carriers. So what would that mean for the removal of sediments? It wouldn't mean that a canal could be simply put into the lake without a massive process of dredging. Since 60% of the lake is less than 9 meters of depth, that would mean that approximately 2/3 of this depth would have to be manually dredged in order to reach the desired channel dimensions. So the dredging, this is an estimated calculation, would mean dredging 750 million tons of sediments. The proposal from the company is a Chinese company, the HKND group, is that all dredged materials would be deposited on the lake bed, constructing 2 artificial islands and a 100-kilometer long wall alongside of the ditch of the canal. What would this mean for the removal and resuspension of sediments on the lake? Of course, this would affect drastically the transparency in the lake, and as following, it would mean a great reduction in primary production of phytoplankton in the water body. This would also mean strong effects, obviously, on the biodiversity of phytoplankton to fish, including the benthic organisms, which points to a most probable overall reduction and simplification of all the biodiversity in the lake in all ecosystem compartments of the lake. It would also mean, obviously, an increase of suspended sediments that would lead further to the degradation of the wetlands and reduce drastically their water filtration capacity. Further, we all know that in the sediments of lakes, there's a lot of storage of nutrients and also of contaminants. So that would mean in the dredging process that you would have a resuspension of these contaminants and nutrients to the water column, formerly stored in the sediments. The release of this to the water column would obviously mean a great impact on the biota, involving bioaccumulation, toxic effects on fish, phytoplankton, and benthic organisms. And the release of nutrients would lead to a stronger acceleration of the eutrophication in the lake. The input of phosphorus and nitrogen from the sediments to the water column could stimulate even more the growth of cyanobacteria, producing cyanobacteria blooms and the consequent effects on the present water quality. The shallowness of the lake makes it even more susceptible to eutrophication. Also, if we had the release of these nutrients and other contaminants to the water column, that would mean that we would have an increase for the demand of oxygen due to the increase in organic matter coming into the water, which could cause conditions of hypoxia and later on also to massive fish kills. There have been fish kills observed in the lake at times where the wind has had 5 or 6 days of wind calmness, so you can observe, due to the lack of oxygen, fish kills. So in overall, this would mean that the water quality and its potential use for the future for human activities as drinking water, water for irrigation, would be as strongly affected by the dredging processes in the sediments. There is a lot of lack of information that we have pointed out to the canal authorities or the planning authorities. Actually, the bathymetric data that I have showed before is based on an old bathymetric study from 1972. So it seems obvious that if you're going to have a new canal built in a lake, that you need new studies done on the bathymetric qualities of the lake and also the quality of the sediments. This lack remains critical because of the large amount of sediment which has been released into the lake in the last 20 years. As I told you, the lake has had big land use changes, and there has been increased sedimentation into the lakes in the last decades. This has also been demonstrated in a study from the World Bank using the land use model SWOT from the watershed, where they estimated 50,000 tons of sediments are released to the lake per day, and only 1,005 tons are translated from the lake to the outlet river of the Rio San Juan. This would mean a total of a yearly sediment yield of about 13.3 tons per hectare per year on the average from the watershed, which is comparable to Lake Victoria. So I would like to enter somewhat into the lake hydrodynamics and the circulation of currents initiated by the intensive wind action, which would mean problems in the operation of the canal. There are really actually no knowledge of the patterns of the activities of the winds and their production of currents inside the lake. The construction of the channel, which lies in the course, could be in the line of mixing currents. It is not known at this time. And so we think it would be somewhat irrational to not have this information for the planning of the route of the canal. And of course, the polymictic character of the lake would create problems in the operation phase of the canal, bringing newly resuspension of sediments into the canal channel. So the process of controlling sediments inside the canal structure, we have pointed this out to the canal planning company. They have not revealed how they plan to keep the channel free of sediments redepositing into the channel structure. Something new that we have been working on lately is the possible seismic activity in the area of the canal. Lake Nicaragua, and you can see this here, is located in the geological Nicaraguan Depression, which is a region which has always been subject to a lot of seismic activity. The lake is situated along the Central American volcanic front with actually two volcanoes on the island of Ometepe, which is in the central part of the lake. So this complex tectonic structure would result in geological risk reflected. For example, there have been events of an earthquake in Rivas, which is one of the towns on the border of on the shore of the lake in 1844, and there was also an underground lake earthquake in year 1985. And lately, in the last 3 years, we have had a lot of constant seismic activity in the southern part of the island of Ometepe. There's been a study done in year 2009 where they studied using geophysics and geology, the current and the past information about the geology of the region and the active tectonics in the surrounding area, where they have located 3 main active faults below the lake bottom. So you can see there's a Jesus Maria, which is 4 kilometers long. There is Morito in this part of the lake, and also San Ramon, which is a fault which has 25 kilometers long. There's also it has been proposed in this study that the lake lies on the exactly on the border of the Nicaraguan Depression. So the projected canal route would actually run parallel to the San Ramon fault zone. And the locks in Burrito, which is on the Pacific coast, would probably be close to the Jesus Maria and the Lake Nicaraguan fault zones. In conclusion, the proposed canal route would be exposed to a significantly high risk of geological risk and seismic activity. I just wanted to conclude, say that the lake really has a lot of potential for the development of Nicaragua, especially under the vulnerability of Central America to climate change. Even the World Bank emphasized that the Lake Cocibolca or Nicaragua is an increasingly important source of water supply for the country and a global biodiversity hotspot. The Nicaraguan water law emphasizes that the lake should be a reservoir or is a reservoir for potable water with a strategic value in the future. The lake at this time, as I mentioned before, has adequate quality to be used as a source for irrigation. Nicaragua is dominantly an agricultural land, so considering climate change, the climate change situation in Central America, it would be a very good source for irrigation and the future development of agriculture in Nicaragua. Nicaragua is actually the 4th most vulnerable country to climate change. This has been determined by the Global Climate Risk Index of German Watch. Therefore, it's obvious that the necessity to have secure water resources for irrigation plans are urgently needed. This is a reference to a recent publication from Professor Tundisi and Nicaraguan scientists. Lake Nicaragua has enormous strategic value as the region's largest freshwater reservoir in the face of the world's changing climate and dwindling freshwater resources. So the construction of the Interoceanic Canal through the Lake of Nicaragua would put all these future uses in danger, and it would mean that the fragile ecosystem and the tectonic risk would mean a risk precisely for the security of the construction and the operation of the canal itself. The impacts on the quality of water and its sediments would make one of the most unique tropical lakes in the world, could change profoundly the lake's ecological, environmental, and economic value for the development of Nicaragua. So thank you for your attention.